have done a good job with it already, is the midterm. So the midterm went up on Wednesday, just like I said that it would. And you have all day today and all day tomorrow to work on it. So again, it is not due until the end of the day Friday, the end of the day tomorrow. So make sure to keep working on that. If you haven't finished it already, that is totally fine. But make sure that by the end of the day on Friday, you get that turned in. That is when it is due. You do have a couple daily assignments to do today and tomorrow as well. But hopefully they should be pretty short. Like I think they're both like 2 or 3 questions long, essentially. And you should be able to get those pretty easily, so you can spend most of your IPC work time today and tomorrow working on that midterm. All right, so no school on Monday. Tutoring tonight at 6:30. I'll post a link in the Google Classroom. And the midterm is still up and going, and that is due by the end of the day on Friday. All right, so does anybody have any questions about kind of general school stuff before we get into our notes for today?
Excuse me, we don't have any assignment. We only have one assignment today, and we don't have more assignment today and tomorrow.
So you have the midterm, which is due by the end of the day tomorrow. And then you have one short assignment for today and one short assignment for tomorrow.
Oh, okay. Okay.
But then on Monday, there's no assignment since it's an off day for you guys. All right, good question. Thanks for checking. All righty, so today we're going to kind of continue on talking about these atoms and molecules and particles and different stuff like that. And on Tuesday, we talked about the ionic bond and the covalent bond and how we can use those to kind of bring atoms together and stick atoms together. Today, we're going to look at what other types of substances can we make by bringing in and bonding together all sorts of different types of atoms. So I'm going to kind of go over a big flow chart of kind of everything that we're going to talk about today. Then we're going to talk about kind of each piece individually, and then go back at the end to the flow chart and kind of show you guys how it all works together. So today is kind of all about classification. How can we tell what kind of matter that we are working with or that we're looking at? So we're going to learn about what are some of the different types called and how can you distinguish between them. So overall, there's kind of 2 major categories of matter that we're going to talk about today. There are mixtures and there are pure substances. And as we'll talk about in a little bit, a mixture is when you have all sorts of different types of atoms and compounds and molecules all mixed together, hence the name. Whereas a pure substance is where you only have one type of molecule, one type of substance. Mixtures, we're going to talk about how we can break them down into kind of 2 different categories. A homogeneous mixture where everything is all equal and even, and a heterogeneous mixture where we have unequal distribution in different pieces in different places. And then we're going to talk about how our pure substances, where we have 100% pure one type of substance. They can either be compounds, where you have different atoms that are chemically bonded together, whether it's an ionic bond or a covalent bond, they're stuck together. Or you can have just a single element on its own, a single atom on its own, and we call that an element. So for now, this all probably is a lot and doesn't make a whole lot of sense to you, but we're going to go through each one of these pieces kind of individually and break down what exactly they mean. So we're going to start with our pure substances, 100% pure, 100% one type of substance. So a pure substance is when there's only one type of particle present in that substance. And there's not different things that are mixed together. It is all one single thing, essentially. So we can sort of break that down into two different groups. We can have elements where we have a single type of atom. So on these pictures and on the pictures on your assignments for today and tomorrow, you have these little dots that kind of represent different atoms. And sometimes they're all on their own, and sometimes they're bonded together. So when they're just on their own, when they're single individual atoms, that's called an element. So all of these are only black dots here, so that means that this is one element. And then a compound is when we have different atoms that are bonded together. So maybe they have some ionic bonds going on, maybe there's some covalent bonds going on. Whatever type of bond that it is, a compound is when there are different atoms that are bonded together. But again, both of these pictures are pictures of pure substances because both of these pictures only have one type of particle, one type of substance. Either on the element side, we have one single type of atom, just repeated over and over again, no other atoms mixed in. On the compound side, we have different atoms, but they're all bonded together in exactly the same way. Each particle in this compound is one black dot and two white dots. So because each one of these substances, each one of these compounds is the exact same, it's still a pure substance. There's only one type of compound in this substance right here in this picture. So if we took some of these elements and sprinkled them around these compounds, then we end up with something different. We wouldn't have a pure substance anymore because we would have more than one type of thing in there. But when it's divided up, when there's only one type of particle, one type of substance present, that is what makes it a pure substance. So a little bit more breaking down of elements and compounds. Like I was saying, an element is when you have matter that is made up of identical atoms. Every single atom in that matter is the same as the ones that are around it. So like in this copper vase, for example, every single atom in this vase is a copper atom. There's no iron or zinc mixed in there. There's no carbon or hydrogen that is part of the vase. It all is 100% pure copper and only copper. Same thing with these gold bars down here. So gold is one of those weird chemicals where its chemical symbol is Au, even though it's called gold. Don't ask me why. It has to do with the old Latin name for gold. But regardless, every single atom in these gold bars is a gold atom. There's no other oxygen or aluminum that's mixed in here. It's all 100% pure gold and only gold. If you're able to look down at the super duper microscopic level, all you would see would be only gold atoms repeated over and over and over and over again. So that's what it means to be an element. Only one single type of atom that is present. No other atoms are involved. So you can have a pure substance that is made up of one single element. You can also have a pure substance that's made of one single compound. So a compound is when you have two or more different elements that are bonded together. So like before, we had that black dot and the white dot, the two white dots that were bonded together. That made it a compound because those elements were different. They weren't the same anymore. It's not like the pure element that we were just saw. Now we've got some different stuff mixed together. So one great example of a compound is salt. So sodium chloride, which you may remember from Tuesday, we talked about, this is kind of the classic ionic bond where the sodium gives its electron to the chlorine atom. And then the sodium's a little bit positive, the chlorine's a little bit negative, so they bond together. Sodium and chlorine are obviously not the same atom. They're not the same element. They are different elements. So when the sodium and chlorine bond together, they make a sodium chloride compound. We call sodium chloride compound salt. So if in this salt shaker, all these crystals here were all 100% salt, so it was all NaCl compounds all throughout the entire shaker, that would make all of this salt a pure substance. This is the only compound that's present. There's no other compounds or elements that are mixed in. It's all NaCl compounds, so it'd still be a pure substance. Other kind of famous or important compounds that you probably have heard about in your life at some point before include things like water. So the tasty stuff that you drink that comes out of your taps. Water is 2 hydrogen and 1 oxygen atom. So hydrogen and oxygen are obviously different atoms. So when they become bonded together, they form a compound. Again, if this glass is made up of 100% totally pure water, there's only water molecules that are in this glass when you go look down at the microscopic level, that would still make it a pure substance because there's only one single type of compound that is present. Carbon dioxide, CO2, another famous compound, famous for a little bit worse things than water. So this is the stuff that you breathe out as you breathe. This is the stuff that comes out of your car exhaust when you drive around, that comes out of factories when they're making stuff. And just like the name says, carbon dioxide means 1 carbon, 2 oxygen atoms. Again, carbon and oxygen are different atoms, so CO2 is a compound. Different atoms that are bonded together. Finally, one of my personal favorite compounds can be found in things like beer and wine and rum and whiskey. It is ethanol. So ethanol is the version of alcohol that we drink. There are a whole bunch of different types of alcohols out there, but ethanol is the one that we like to use to put it, that is made as part of our beverages. So ethanol is a compound. It's a little bit bigger than these other ones that we've been talking about. It has 2 carbons attached to 5 hydrogens attached to an oxygen-hydrogen group, usually called an OH group or an oxide group. But these are all fused together. They're all stuck together. And obviously, carbon and hydrogen and oxygen are different atoms. So that's what makes this still a compound. Different atoms, different types of atoms, but they are still bonded together. They're fused together with each other. So water, carbon dioxide, ethanol, all compounds. They're made out of 2 or more different atoms, and it's still possible to make a pure substance out of compounds. If there's only 100% pure water or pure carbon dioxide, and that's the only compound that's in your solution, then you have a pure substance. That's the only one single type of particle that's found in there, either all water particles or all carbon dioxide particles, and so on and so forth. All right, so elements are when we have single atoms that are on their own, that aren't bonded to anything different. Compounds are when we have different atoms that are bonded together. All right, and if we have one single element or one single compound in our set, in our substance, then it is a pure substance. There's only that one single type of particle that is present. All right, so does anybody have any questions about compounds or elements or pure substances so far?
No, sir.
No, sir.
Nope.
Righty. Cool. So for example, the water that I'm drinking right now inside of my cup is probably not a pure substance, because even though it did come out of the tap at my house and then went through a Brita filter and then sat in my fridge for a little while, there's still all sorts of different compounds that are part of your water. Obviously, the city of Austin or Cedar Park or wherever you live does its best to try and keep the amount of bad compounds really low, which is why it's safe to drink your tap water in most situations. But there's not going to be 100% pure water coming out of your tap. It's probably going to be mostly water with a few other compounds and elements mixed in. So when that happens, when we have something that is not 100% pure, but maybe has different elements and different compounds all combined and swirled around together, it's no longer a pure substance. Instead, we now have a mixture. So a mixture is when we take two or more pure substances and put them together, usually a lot more than two pure substances, all sorts of different combinations of materials. So it's multiple different particles all mixed together, hence the name of a mixture. So as before, we would have a single element or a single compound all together. Now in our mixture, we have all sorts of different things. So we have this black atom, we have this black and white atom fused together, and we have this guy right here, which is a white atom fused to itself. So this guy we haven't specifically talked about before, but if you think about what we've talked about, if an element is a single type of atom and a compound is when you have different atoms that are combined, that are bonded together. Would this guy right here, this double white substance, be an element or a compound?
So on this one, on mixture, we have we have element and compound also.
We do have different elements and compounds, but specifically this one right here, where it's the two white atoms that are together, is this an element or a compound?
Oh, yes.
So remember, an element is when there is only one type of atom. A compound is when there are different atoms that are bonded together. So if this is two of the same atom together, is it an element or a compound?
An element?
Yeah, exactly. So even though there's two of them, it's two of the same atom. So it still technically is classified as an element because it's not different atoms together. It's the same atom, the same type of atom. It just, instead of being on their own, this particular atom likes to group up into pairs. You see this a lot in nature, especially with gases. Things like oxygen tends to float around in the air as O2 gas, two oxygens together. Same thing with hydrogen. Hydrogens like to clump up in groups of two. And so you have H2 gas, hydrogen gas, but it's still an element because it is the same atom. These aren't different types of atoms. They're the same atom. It just happens to be, instead of floating around as a single atom, they're together as like a double atom. What about a little bit easier question? What about these guys right here? So you have this one and this one and this one over here. Are these guys elements or compounds?
Compound.
Yeah, compounds, precisely. We have the black atom and the white atom. They're different, but they are bonded together. They're fused together, which makes it a compound. And then finally, what about this one single type of black atom on its own? Is this an element or a compound?
Element.
Element, exactly.
Oh, I have wrong assignment on number 2 today. Oh my goodness.
That is okay. You are free.
I click poll. We have compound and element.
Mhm. All right, so before, when we were talking about pure substances, we only had one type of substance in that matter. Now, in mixtures, we can have lots of different particles, lots of different substances, all combined into one. So now we have this black element, we have this double white element, we have this black and white compound, all combined together, elements and compounds both, into a mixture. So because we have all of these different parts, all of these different compounds and elements that are present, we can say that it is a mixture. It is no longer a pure substance.
I have a question. So the two double white, the white ones, that's an element?
Mm-hmm.
Okay.
It's still classified as an element because it's not different types of atoms. They're both the same type of atom. And so even though they're together, since they're the same type of atom, it's still just one element.
Okay, thanks.
No problem. Good question. So we can sort of classify our mixtures into two different types. The first type is called a homogeneous mixture, also sometimes referred to as a solution. So in a homogeneous mixture, it means that all of the different components, all of the different atoms and compounds are all equally and evenly distributed. You have the same amount of atoms and compounds in every single different part of your mixture. For the most part, this tends to happen when the particles are a little bit smaller. It's easier for them to be kind of evenly spread around and spread out. And so homogeneous means equal and even. Everything is the same throughout the entire mixture. So one good way to think about this is, I like to kind of think about it as every single area, every single piece of this mixture should have the exact same combination of elements and compounds. Meaning that in things like medicine, like these eye drops right here, right? Usually it's a mixture of water and salt and some eye medicine to help kind of clear out your eyes. Every single drop out of this little eyedropper should be the exact same, right? You shouldn't have a situation where the first couple drops are like really, really watery, and then the last couple drops are like super concentrated and maybe like hurt your eyes a little bit. The medicine and the water and the salt should all be completely evenly mixed throughout the mixture. you should have the exact same mixture of chemicals, of compounds in here. So some other good examples that I think kind of help bring the point home. Things like mouthwash. So whenever you wash your mouth out with this stuff, you should be getting the exact same combination of water and mint, and some of them have like a little bit of alcohol in there to help kill the germs. But it should be the exact same every time. You shouldn't be getting some ones that are like super powerful and concentrated, and some ones that are really diluted and not really doing anything. All of the compounds and elements should all be totally evenly distributed throughout this bottle from top to bottom. Same thing with things like other household things like vinegar. So vinegar is a mixture of water and a compound called acetic acid. And so if you're using your vinegar in cooking or for making cleaning solutions, every single little capful of vinegar should be the same. Whether it's from the top of the bottle, the middle of the bottle, the bottom of the bottle, every single time that you pour out some vinegar, all of the components should be totally equal. So you should be getting the exact same amount of chemicals in every single pour from that vinegar bottle. Same thing with coffee. If you're using like the traditional like drip coffee style maker where you have the grounds held up at the top and the water comes through and drips down and turns into a nice brown color, every single sip of this coffee should be the same, right? It should be the same combination of water and caffeine and coffee flavoring in each sip. It shouldn't be a different taste from the start of the coffee to the end of the coffee. Now, obviously, if you like let it sit out for a couple days halfway through, then yeah, it's probably not going to taste too great. But if you pour out multiple cups of coffee from this one pot, every single cup should taste the same. It should have the same even and equal distribution of ingredients. Some coffee makers aren't like this. They don't make homogeneous mixtures. There's a type of coffee maker called a French press. I don't know if any of you guys have one. My wife is super into coffee and tea and stuff like that. And so she has like all sorts of different coffee related gadgets, which I'm like, go for it. I'm not going to drink it anyways. Coffee's gross. But she likes to sometimes make it this kind of fancy French press style where you mix the grounds and the water together in one container. And then you use a little plunger to push the grounds down to the bottom of the container. So all of the grounds and coffee beans are held at the bottom, but the flavor can still circulate through the liquid part. That would not be a homogeneous mixture because now you have liquid coffee sitting on like the top of the container, but these ground up coffee bits down at the bottom. So all of the pieces of your mixture are not equally distributed because you have this liquid part and the solid part all kind of stuck together. So that would not be a homogeneous mixture. But if you make it in like the old school coffee maker where the water drips through the filter and down into the pot, but all the beans stay up on top of the filter, then you do make it homogeneous. And then finally, one of my personal favorite examples, peanut butter. I don't know about you guys. I love peanut butter. I could eat it on just about anything. But peanut butter is a mixture of ground up peanuts and oil, and usually a little bit of sugar and salt added in there for flavor. So just like with our other examples that we were talking about, peanut butter, but only creamy peanut butter. So crunchy peanut butter doesn't count. But creamy peanut butter is a homogeneous mixture. The like typical one that you get in the big red container, whether that's like Jif or Skippy or the HEB brand, every single scoop out of that peanut butter should be the same. It should have the exact same combination of sugar and peanuts and oil mixed in there. So from the first scoop to the last scoop of the jar, every single scoop should have the same taste and the same combination of ingredients. Now, things like chunky peanut butter would not be homogeneous because now you have these big chunks of real peanut in there. And some areas might have more chunks and some areas might have less chunks. So every single scoop isn't going to be 100% the exact same. Also, sometimes, I don't know if you guys have ever tried, you can get like fancy all natural style peanut butter at places like Whole Foods and Central Market and stuff like that. And that peanut butter isn't quite as processed, which means that a lot of times the oil from the peanut butter will kind of come out of the solution and sit on the top. And so every time that you open up the jar, you kind of have to remix it to get all the oil to mix in there. For me personally, that's too much of the hassle. I'll just take the Jif every time. Thank you very much. But that kind would also not be homogeneous, at least until you mix it, because now you have the oil kind of sitting on top and all the other pieces sitting underneath. So everything is not totally even and equally distributed. So it is not a homogeneous mixture. But normal, kind of store-bought, smooth peanut butter is a great homogeneous mixture. Every single scoop, every single piece from that peanut butter should be the exact 100% same. All right, so what do we call it if it is not 100% the same? What if there's all sorts of things mixed around in different ways in different places of our mixtures? In that case, it's no longer a homogeneous mixture. Now it is called a heterogeneous mixture. So a heterogeneous mixture is when we have an uneven distribution of our components. Not everything is totally evenly and equally separated. There may be some areas that have more of one type of compound and some areas that have a lot less of this specific type of element. So it's heterogeneous. It's not equal and even. So some areas might have a high amount of particles that are really clumped together. Other areas, those same particles may be way more spread out far apart from each other. So a heterogeneous mixture, you're not getting the same mixture of particles in each piece, in each area of the mixture. So something like granite is a good example of this. Granite is a rock that people really like to cut up and put on their kitchen counters and countertops. Granite is a rock which is made out of a whole bunch of different minerals. And so granite gets this very speckly kind of look to it from all of those minerals. Now, if granite was homogeneous, then you just see one kind of blank grayish, brownish, like one color across the whole thing. But it is not. It is heterogeneous. So instead, you get all of these tiny little clumps of different minerals. So some areas have these little black clumps from these black minerals, and then there's also these white minerals, and then these kind of grayish minerals and brownish minerals. And they're all clumped up in different areas in different ways of this granite. So like if you're to cut out pieces of the granite, this piece of granite doesn't look the exact same as this piece of granite. There's a different way that the minerals got mixed and fused together. So that's what makes it heterogeneous. It's not completely 100% the same. Other good examples of kind of everyday heterogeneous mixtures that you may have encountered, but probably didn't think of them this way, would be something like a salad. So in this salad over here, it looks great. We've got spinach, we've got strawberries, raspberries. I can't tell if this is cheese or like it looks like cheese, like feta cheese or something like that. We've got blueberries, we've got either mango or pineapple. We've got almonds, it looks like. So every bite that you take out of this salad probably isn't going to be the exact same. If you start eating over here, maybe you're going to get a whole bunch of spinach. If you take this bite that's on this fork, you've got the raspberry and the mango, but you're missing any of the strawberry and the blueberry. So every single bite is not going to be the same. All the different pieces of the salad are not completely evenly mixed. Now you could potentially turn this into a homogeneous mixture if you dumped your salad into like a fancy blender and then blended it up for a couple minutes. Then you'd probably get a kind of weird, gross tasting salad, but it would be a little bit more evenly distributed. But instead, the way that we would prefer to eat it, at least for me, is going to be a very heterogeneous mixture. Lots of different pieces, some in higher numbers in one area versus another area. So every single piece is not the exact same. Same thing with this dressing over here. So this zesty Italian dressing. You can see it's a base kind of made out of what looks like a combination of water and oil. But then we've got all of these different little clumps in there. So I think these are like clumps of garlic and red pepper, maybe, or something else. But all these little clumps floating around in the sea of water and oil mean that the garlic and the pepper are not completely evenly mixed in with the oil, right? All of these little pieces, all these little clumps mean that some areas might have more pepper and less garlic, and then other areas have more garlic and less pepper. So it's not completely even and equal. We have different amounts of flavorings in different areas. Finally, to get away from kind of the food categories, if you reach your hand down into the dirt, if you go outside into a dirty area and reach your hand down and pull up a whole bunch of soil, you're probably going to see a whole bunch of different things in that soil. Sure, there's going to be a lot of dirt, but there also might be some rocks, there might be some sticks, there might be some ants or like bugs that are crawling around in there. Maybe the soil that's in your hand looks different from the further down soil in the ground. So soil and dirt is another great example of a heterogeneous mixture. We have not just different things in the soil, like roots and twigs and rocks, but we also have even different makeups of the soil itself. So the part on top is a lot more kind of loose and dirt-like. The one in the middle seems like maybe it's more like clay, like more sticky. And then the bottom is maybe more rocky, like a lot of bedrock and stuff down there. So even the different levels of the soil are different. So because not everything is totally evenly and equally mixed and distributed, because we have these different layers, because we have all these big chunks of rock and sticks that are mixed into our soil, it is not a homogeneous mixture. This is a very, very heterogeneous mixture. Different pieces and different amounts of things in different areas. All right, so before we go back and review everything again, does anybody have any questions relating to mixtures or homogeneous mixtures or heterogeneous mixtures?
No, sir.
All righty. So again, just to kind of bring everything that we just talked about together under one roof, we have our matter, our substances, our stuff. Don't necessarily worry about what all the little descriptions of the arrows mean. We didn't really go over those specifically. But in our matter, we can either have only one type of substance or lots of different substances. If we have only one type of substance, it is a pure substance. That is the only type of particle that is in there. If we have lots of different particles, lots of different elements and compounds all together, then we have a mixture. Now, in our mixtures, we can have a mixture where we have very small particles that are all completely evenly and equally distributed throughout the mixture. That would make it a homogeneous mixture. If it is not all even and equal, if there are clumps of particles, if there's more in some areas and less in other areas, then it is not an even mixture, and it is called a heterogeneous mixture. So homogeneous, equal; heterogeneous, not equal, not even. If we go back to our pure substances, or we look at the different types of things that can make up our mixtures, then if we have different atoms, different types of elements that are bonded together, we have a compound. So 2 or 3 or 4 different types of atoms that have all chemically bonded together, whether that's ionic bonds or covalent bonds. As long as it's different atoms together, it is a compound. If it is just the one single type of atom, that's the only atom that there is, there's no other different atoms in our substance, then it is a single element. So we talked about how we can have the one single atom on its own. We can have 2 of the same atom that are together. They're still an element because they're both still the same atom. No different atoms means not a compound. So element, one single type of atom. Compound, when you have multiple atoms, multiple different atoms that are bonded together, are fused together. We can take different elements and compounds and put them together to make a heterogeneous mixture where they're not equally distributed, or a homogeneous mixture where they are equally distributed. Alrighty, does anybody have any final questions about mixtures, pure substances, heterogeneous, homogeneous, elements, compounds? Any questions about anything that we've gone over so far here today?
No, just only that it was the assignment we had like 2 days ago. I was working on still. It's the only reason I ain't finished it because I don't understand this. Well, I just go to, I don't know if I should go to it real quick. Well, yeah, it's gonna hold up time. I guess I'll bring it back to you, or just text it on there where I need help at and explain. Cause I don't know if I understand it all the way. But it ain't this. I understand this. But it was just one simple as something else. Like 2 days ago.
Gotcha. Yeah, if you want, at the very end of today, I'll pop back to some of the older stuff.
Okay.
Go through that a little bit. No problem.
All right, thanks.
Yep, no worries. Alrighty. So for your assignments for today and tomorrow, like I said, I try to make them pretty short so that they're pretty easy to get through and still have time to work on the midterm. It's basically the same type of questions for Thursday and Friday, just a little bit different substances that you're going to be looking at. So the first part of it is kind of a little bit of a review, shows you some different examples of like elements that we've been talking about, example of a compound, a mixture of elements and compounds together. It provides a little bit more of an example of down at the particle level, what it might look like with a homogeneous mixture. So you can see in this one, we have 3 different substances, white element, black element, and white and black compound. But they're all pretty evenly distributed, right? There's no areas where there's obviously a lot more of one type of particle than another one. There's about the same number of particles from each different type, and they're all distributed fairly evenly across this diagram. This other diagram over here is a very, very heterogeneous mixture. So we have the exact same components, but now we have all of the black element is over on the left side, and all of the black and white compound is kind of grouped up in the middle, and then all of the white element is grouped up over on the right side. So obviously this is totally uneven distribution. We don't have an equal amount of particles in each area of the mixture. So that's what makes it heterogeneous. So what you guys are going to do is on this one, I think there's 2 substances. Yeah, And then on Friday's assignment, there's 3, I think. So for each substance, I want you to tell me 2 things. First, I want you to tell me, is this a pure substance, a homogeneous, or a heterogeneous mixture? And then the second question I want to know is, what type of particles are present? Are there only elements that are present? Are there only compounds that are present? Or are both elements and compounds present? So that's what the both answer down here means. It means that there's elements and compounds in this substance. So like I said, you have 2 substances that you're going to look at for today's assignment, and then 3 substances set up in the exact same way for Friday's assignment. The Google Doc version is pretty much the exact same. Obviously, it's the exact same substances, only instead of having the options that you can pick, you just have to write in, and I try to make it as clear as possible on the directions up here. So if you like doing the Google Doc version, make sure you read the directions. So on the first line of each substance, you'll write in if it's a pure substance, a homogeneous mixture, a heterogeneous mixture. And then on the second line for each substance, you'll write in if it's only compounds, only elements, only compounds, or both elements and compounds. So again, exact same substances for Thursday and Friday's homework, just a little bit different way of writing in your answer. All right, so like I said, both today and Friday's assignment should be pretty short and sweet so that you have plenty of time to work on the midterm, which again, the midterm is due on Friday. So you have all day today and, well, I should say the rest of the day today and all day tomorrow to work on it if you need to. All right, does anybody have any final questions about any of the notes or anything from the Google Classroom that we went over today?
No, sir. Have a good weekend.
All right. So as always, if you do ever have any questions, please reach out to me. You can shoot me a text, you can send me an email, you can leave a comment on the Google Classroom, and I'll do my best to get back to you as soon as I am able to.